So in this lesson, we're going to talk about the graphs of y equals sine of x, y equals cosine of x, and y equals tangent of x. And we're using these now as functions. And since we have never done this before, I'm going to go into great detail of how you can plot these points and then connect them. But really, in the end, I only really need the general shape with, of course, some appropriate values. So anyway, so here is my table. This one is y equals sine of x, and I'm going to make an x and y table. And I made a bunch of values, convenient values, all the way from 0 down to 2 pi. I added pi over 4. I went by a scale of pi over 4 every time. So 0, pi over 4, 1 pi over 4, 2 pi over 4, which turns into pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And then recall that the sine function, once I've gone through 0 to 2 pi, I'm dealing with coterminal angles, and so the y-coordinates, the outputs of this sine x, will repeat themselves. Think of it as sine theta, and this is now whatever the ratio is that I'm dealing with. So the x's are actually angles, and the y's are really the ratios that we get. And again, because I'm graphing, I don't really need radicals like root 2 over 2. I'm just going to use the decimal approximation. In fact, one decimal place is good enough for me to get a general sense of what the shape of the graph is. So when x equals 0, I'm doing sine of 0, and that's 0. Sine of pi over 4 is going to be approximately 0.7. I'm going to get sine of pi over 2 is 1, and then 3 pi over 4 sine of 3 pi over 4 is 0.7, etc. And I have 0, 0.71, 0.70, negative 0.7, negative 1, negative 0.70, and then it'll start again, and it'll do the same list again. And so in black here, I have plotted these points. That's 0, 0. That's pi over 2, about 0.7. Sorry, pi over 4 and about 0.7. That's pi over 2 and about 1. That's 3 pi over 4 and about 0.7. That's pi 0, etc. These black dots here are the points that I found over here. And then I would connect them to get this wave-like thing, which then will repeat exactly the same over and over and over, and even going to the left. So this is often called a sine wave. Now, a wave has certain properties. One of them is called the amplitude. The amplitude is essentially if you go from the middle, the maximum height above the middle or the maximum height below the middle that you might go. In this case, the wave has an amplitude of 1 because it goes up to 1, it goes down to negative 1, and that's as far high or low as it ever gets. So the amplitude is, in this case, 1. And there's also such a thing called the period, often known as the fundamental period. And the period is the horizontal distance that you have to travel before you start repeating yourself. So in this case, the period of the wave is 2 pi because you have to make one wave fits 2 pi, and then you start drawing it again. So the period in this case, or the fundamental period, is 2 pi. Now, if you remember the amplitude and the period, great. If not, don't stress over it. Really what you need to know at this stage is the general shape of the sine wave. So here's the graph of y equals cosine x. Once again, what I did was I started by plugging in points 0 through 2 pi, and I got the y-coordinates, where the outputs, the x over r values that you get for all of those angles: 1, 0.7, 0, negative 0.7, negative 1, negative 0.7, 0, 0.7, and 1. And then I plotted those black points here from the values that I got in the table. And of course, remember, after 2 pi, you get coterminal angles. In fact, 2 pi and 0 are coterminal, so the 1s are actually the same point, just repeated. And so I connected those into this another wave, which is, you can call it the cosine wave. But it's actually often just called a sine wave. Generally, they are called sinusoidal waves. And it's because you can actually do a translation of the sine wave to get to the cosine wave. So the cosine wave is just a sine wave that got moved to the left by pi over 2. But that's neither here nor there. This is the graph of y equals cosine x. Generally, you need to get the shape of it. The key points are here that the graph starts at the top of the graph, right there, and then it goes down from there. The amplitude is still 1 because it goes up to 1 and down to -1. The period is still 2 pi. Let's write that very quickly. Amplitude is 1. And the fundamental period is 2 pi. Again, if you don't remember that, don't stress over it. Okay, here's the graph of y equals tangent x, and once again I plotted a bunch of points. I figured out all their values here, 0, 1, and then tangent pi over 2 is actually undefined. When a function value is undefined, it often means, and in this case it definitely means, that there's an asymptote, a vertical asymptote. So at pi over 2, there's a vertical asymptote. Same thing happens at 3 pi over 2. There's another vertical asymptote. And of course, at 2 pi, you've got coterminal angles, so the whole pattern will repeat itself. In the meantime, though, there's these values, these points here at 0 and at pi over 4, comma 1. And then there's 3 pi over 4, comma -1, pi, comma 0, 5 pi over 4, comma +1. And what ends up happening if you fill in more details is you get these sort of curvy things, these S-shaped curves. Notice it is not horizontal. It's not like a triple root when you do polynomials. It's actually slanted. The slope there is actually 1, but that's neither here nor there. And you get this one, and then you start getting the same one over and over again. And it turns out that this is still a periodic function. You can still get a period. In this case, the period is actually just pi. It didn't actually take 2 pi before it started repeating. The fundamental period is just pi because, after all, this wave only took up a space between negative pi over 2 and positive pi over 2. The width is pi. And then you drew it again. So the period is pi. Now, there is no amplitude because the graph goes up and down forever. So either you say there is no amplitude or you say the amplitude is infinite. Typically, we just say there's no amplitude. This is not a wave. This is a different kind of a graph because you don't get this sort of smooth, wavy features. Instead, you get these sort of S shapes that disappear and then another S shape shows up, etc. So that's the graph of y equals tangent x.